In our previous lesson, we talked about the rate of reaction. We got to see that rate had to do with time, how reactants disappear or how fast products appear. That is what rate of reaction is all about. So whatever we are seeing compared to the time in which we are seeing it. Now this is a practical way of measuring rates of reactions. In reactions where a gas is evolved, the volume of gas is collected using a gas syringe. So here the reaction is taking place inside the conical flask. Now this is a closed system. It is a closed system because there is no interaction with the surroundings. Here the reaction is taking place. This reaction is going to produce gases. Now we connect this tube, delivery tube, to the gas syringe and make sure it is airtight. No air is entering. The same applies to this delivery tube inside the cork. Now as the gases are being produced, we measure with time at regular intervals. What regular intervals means is that if we are talking about seconds, we are going to measure at regular intervals of seconds. So we say 1 second, we can measure at 2 seconds, 3 seconds, 4 seconds, or we can say, or we can decide to measure at 10, 20 seconds, 30 seconds, 40 seconds. So that means the distance or the space in between the two times are the same. But when we measure at 1, 5, 6, 9, 12, these are irregular intervals. So regular intervals have the same numbers or differences. Okay. Now for a very fast reaction, the measurement is taken in seconds because it is very fast. The gases will be produced very fast. But for a very slow reaction, which could take hours, some could even take days, you could measure in hours or minutes. Your intervals should be in hours or minutes. So we can say for every 1 hour, you check the volume of gas produced. For every 30 minutes, you can also check the volume of gas produced. Now the volume of gas produced versus the time in which it is taken, or the time intervals, will be used in a graph. Now a graph is plotted with volume of gas per unit time as the y-axis. So here volume is on the y-axis, the y-axis is the vertical line, and then the time on the x-axis. You're going to see that the values the reactions are going to give you, the reaction is going to give you, will form a graph. If you decide to plot it, it is going to give you a graph. Now you're going to see that when the concentration of the reactant is very high, the rate is the fastest. The rate is the fastest because the slope of the graph is steep or steeper at this end. Now getting to the midsection, as the reactants are halfway used up, the reaction gets slower. So in the middle, as the reactants are halfway used up, the reaction gets slower. Now in the end, as all the reactants are used up, the curve will flatten. So that means the amount of gas in the syringe will be the same. It will not increase, neither will it decrease.